In this example, we've been given two graphs, F in blue and G in red, and we're going to combine them with multiplication in the first part, and we're going to combine them with division in the second part to be able to come up with a new graph. So what we want to do first is we want to make sure we understand what the domain is going to look like, because that'll affect what coordinates we can use to generate our graph. So in this case here, we have our f of x function. It's a restricted square root function starting at x equals -3, and g of x is all real numbers. So the domain of this combined function is going to be x must be bigger than or equal to -3. So when we start generating a table of values, we really should start with -3, because that's our domain. That's the starting point on the very left-hand edge. And when we plug -3 into this expression, the value of y is 0 here. 0 times anything is going to be 0. So that's our first coordinate, is 0, -3, and 0. So I'm just going to plot that here. So once we have that coordinate, then we can take a look at what other points might be useful. Well, since this is a product, each of these functions represents a factor. And anytime a factor is equal to 0, we're going to get a 0. So in this case here, we have x equals 0, y equals 0 from this point, from the g of x function. And again, 0 times anything is going to give us the y equals 0. So we're going to have a coordinate at -3, 0, and 0, 0. I kind of want to know what's happening in between -3 and 0. So I'm going to choose a point that's convenient. In this case, I'm going to maybe look at -2, because -2 gives me some very useful coordinates here. So when we have -2, the f of x is going to be equal to +1. The g of x is equal to -4. So +1 times -4 is going to give me -4. So I'm going to have -4 and -2 as a coordinate, or sorry, -2, -4 as a coordinate. So at x equals -2, y equals -4. So I'm going to have a point down here. Now it looks like it's going to go something like this. Now we probably should have one more coordinate, a few more coordinates to the right of that 0. So I'm going to maybe choose, again, a convenient point. I'm going to choose x equals 1, because that gives me a nice square root point at y equals 2. And that at x equals 1, we have y equals 2. So at x equals 1, we have y equals 2 times 2 for the combined function. That gives us y equals 4. Okay, so it looks like it's going up fairly steeply. Based on my domain, x is greater than -3. We know it's going to go up like this. We don't exactly know where the vertex is, but we know it's going to come through the 0 and keep going up. So that's what the combined function looks like when we multiply those functions together. For part B, we want to divide these two functions. So when we divide these two functions, we still have the domain restriction of x is greater than -3. However, because we have the g of x in the denominator, the g of x cannot be equal to 0. So this cannot be equal to 0. Well, that means that the g of x function cannot be equal to 0. So this represents a restriction. Okay, at x equals 0, g of x will equal 0, so x cannot equal 0. And not only that, that's going to generate a vertical asymptote, because we're going to be dividing by 0 here. Okay, so x is not equal to 0. That's this point here. And we're going to generate a vertical asymptote along the 0. Okay, so I'm going to start plugging in some points here. So x equals -3. That's my domain restriction. When I plug -3 into my equation, I get 0 in the numerator for f. And it doesn't matter what the g is, because we know that the numerator equal to 0 is going to give me a 0. So that's my one point here. That's my starting point. I've got a vertical asymptote. I don't know if it goes down like this or up. So I need to maybe test a point in there. But before I do that, I really should look at potential horizontal asymptotes. And this idea here that the limit as we go to infinity, if we have weaker function over a stronger function, it's going to tend towards zero. Well, in this case, the f of x function is a square root function, or power 1/2. The g of x in the denominator is power 1. So we have a weaker function in the numerator and a stronger function in the denominator. So in this case here, the limit as x goes to infinity of our f of x over g of x, this will equal 0. So as we go to infinity, we know that we're going to have a horizontal asymptote here. So that's good to know. We have a vertical asymptote, we have a horizontal asymptote. So we can just plug in a few coordinates and we can just follow the asymptote. So I'm going to again plug in -2 to generate a y coordinate. So at x equals -2, our y value from the f is equal to 1. The y value of g is equal to -1/4. Okay, so we're going to have 1 divided by -1/4. That's going to be, sorry, -4. So we're going to end up with -1/4. So at x equals 2, we have -1/4. So we know it's kind of going to go down. So we know our graph's going to go down in that direction and follow the asymptote. We want to probably know what's going on the other side of the asymptote. So I'm going to plug in x equals 1. So at x equals 1, the numerator is going to be equal to 2. The denominator is going to be equal to 2. Well, 2 divided by 2 is going to give us a y coordinate of 1. So there's another point there. So we know that it's going to follow the asymptote, go through that point, and follow the asymptote here. We know it has no more zeros because there's no more zeros in the numerator. So we know it doesn't cross the x-axis again. And it's just going to follow the asymptote like this. Now, again, if we want more detail on this and we're not sure about things, we can test a few more coordinates to give ourselves a pattern. But essentially, if we have our vertical asymptote, our horizontal asymptote, we have our starting point and a couple coordinates, we should be able to follow the asymptotes to draw this graph that looks like this.